Hello, this is Team 19's interim presentation. This team consists of Lorenzo, Michael, Brian, Alex, and Nick, and we will be discussing the design of a mechanical keyboard. As previously stated, our product is the mechanical keyboard. For the base model, we chose one that will be hardwired into the computer. We use the standard QWERTY design. Those are the first letters on the keyboard starting from left to right at the top. And the key components of our product are the keys, which consist of the key head and the connection into the keyboard, the exterior shell, the internal electronics, and the base. Our primary customer would be businesses. The pros for them are that it has low cost, a basic design, it's reliable with that direct connection to the computer, it has low maintenance. The cons for businesses is that it's not the most ergonomic design, where their employees may be using this for several hours at a time. For the home user, the pros are the same: low cost, reliable, and low maintenance. However, the cons are that it has minimal customization and the base model is tethered by cord, which may not be ideal if they wish to use it on multiple computers throughout the house.
So this is the functional analysis, or FAST, for the keyboard. The key function of the keyboard is to process text that the user enters. And the 5 key subfunctions of this is to generate signals, process signals, provide feedback, and then assure dependability and ergonomics. Based off of generating signals, the keyboard needs to accept electricity and create an electrical pulse. It needs to process signals, and based off of that, it needs to contain these electrical pulses and then assign pulses to text or to letters or numbers. And then it needs to be able to provide feedback, and that includes providing a tactile response and then communicating the text or an entry.
Here we have the fishbone assembly diagrams for the assembly sequence analysis. One of the key differences between the diagrams for sequence 1 and that of sequence 2 is that sequence 1 uses the PCB as a base for assembly, whereas sequence 2 uses the rear shell of the keyboard. Using the PCB as a base is actually detrimental to assembly, as PCBs tend to be thin and fragile, so they must be handled with care. Sequence 2, on the other hand, mounts the PCB into the rear shell before mounting other components, which offers a firm base that does not need to be handled cautiously. Sequence 1 mounts the keycap stabilizers and the keycaps before the key switch subassemblies have been mounted to the PCB, requiring that all 88 keys are individually held multiple times. Sequence 2 simplifies this by first mounting the key switches to the PCB, which provides a large solid surface on which to mount the stabilizers and switches, in addition to reducing the number of times each individual key must be held from 3 to 1, drastically reducing overall assembly time. Shown here is a chart analyzing ease of assembly for each sequence. Sequence 2 has superior ease of handling as it uses a more solid part as the base of assembly. Mounting each key switch before mounting the caps and stabilizers also means that they don't have to be individually tracked down after being mounted the first time, and these advantages of sequence 2 are reflected in the chart.
Using a function component mapping matrix, we found that out of our 12 parts, the faceplate has the most functions. It protects the inside of the keyboard from most dirt and from impacts. It keeps all the switches in place and has markings on it indicating what some buttons do. We also found out that indexing or positioning is the most used function, which makes sense since this is a mechanical keyboard. All the parts need to line up and need to stay in place before, during, and after each keystroke.
So this is the bill of materials and rough cost estimation slide. So for bill of materials, we have the rear shell, which is the backing of the keyboard. We have the PCB, which is the electronics of the keyboard. We have the upper housing, bottom housing, stem, coil spring, crosspoint contact, and those 5 components lie underneath the keycaps and basically are the mechanisms by which the keys are pressed. We have the mounting plate, which is the top portion of the keyboard that faces the user. Stabilizers, which keep the keycaps in place. Keycaps themselves, which have the text on the top. And then we have the USB to computer output, which is what communicates between the computer monitor and the keyboard.
Finally, our team looked at product family design. We focused on the two groups of customers, the industry and the home users. For the industry, we wanted to focus on a simple, robust design, and for the home user, we wanted to have improved ergonomics. In the assembly diagram, you can see that the main components of the keyboard are all the same until the very end, where the keycaps are different for ergonomic improvements and the computer connection is different, allowing Bluetooth for hobbyists. This differentiation is pushed all the way towards the end of the assembly. And that concludes our interim presentation, and we'll now take any questions. Thank you.